Good evening to all. Today we are going to discuss about the breakdown in transistors. So already we have discussed this breakdown concept, transistors and amplifier. So after this we have completed. Uh, Today we are going to discuss about this breakdown in transistors. So already discussed in PN junction diode, what is breakdown? Breakdown means the device is going to off condition. So that there will be some possibility of voltage breakdown in the transistor at high voltages, even though the rated dissipation of the transistor is not exceeded. That means some cases, even that particular threshold voltage level or the high voltage is not reached, the transistor is going to cut off. Your transistor is going to break down. So there is an upper limit to the maximum allowable collector junction voltage, because the breakdown mainly happens during the reverse bias only. So only we are going to take this as a collector junction voltage. Okay. So based on that breakdown, we have two types in the transistors. So one is avalanche multiplication or avalanche breakdown, that is exhibited due to the thermal heat, and the second one is reach through or punch through. That also it is related to the concept of ALE effect. What is ALE effect? ALE effect is the process in which the depletion layer gets increased when the reverse bias voltage VCB is increased. That particular thing is which will be reducing the effective base bits. That reducing the effective base bit, because of that all the emitter current which is transferred will be reaching the collector through the base. So it is called as reach through or punch to the collector. Okay. So first is reach through or punch through. According to the early effect, the width of the collector junction transistor region increases with increased collector junction voltage. What is that voltage? It is nothing but the VCB. While you are going to increase the VCB, all actually the base, the effective base bit will be reaching the junction of the emitter. So this is your, so like this you are having your transistor NPN. This is the depletion layer of this region. Now this will be your effective base fit. That is the remaining area in the base region is effective base fit. This one. Now this depletion region is coming towards this junction. So this also going to become occupied. That is, the depletion region reaches the emitter junction. So this is the emitter junction. Completely across the base to reach the emitter junction, as the base is very thin. Okay. So thus the collector voltage has reached through the base region. This effect is known as reach through or punch through. Okay, which is known as the reach through or punch through, which affects the output characteristics of the transistor. That means your voltage of output current is going to change. So the output characteristics we have discussed like this, right? For some constant IB. So suddenly this goes to increase if this happens. Okay, that is your avalanche breakdown. So the input, because of this, the input impedance is also affected. So but this automatically reduces your efficiency or else gain. Understand? So this is the first type of your breakdown, and the second type is the avalanche multiplication or avalanche breakdown. So what is this avalanche multiplication or avalanche? This also happens during when the diode is reverse biased. There is a limit on the voltage that can be applied, which is called as the avalanche voltage. So when this reverse bias, there will be some breakdown voltage between the collector and the base terminal with the emitter terminal open. That is called as BVCBO. That is called as BVCBO. That is from the BCB, there will be some threshold level which makes the diode to break down. That is BCB. This breakdown, because of the majority ions present in the depletion region in the collector base junction, what happens is there will be an kinetic energy which makes the immobile ions due to the electric field to collide, which may which may produce more immobile ions. So as a result of this, there is a multiplication in the output current. So the output current M becomes M into ICO, where M is the avalanche multiplication factor. Similarly, your gain becomes alpha into M. All because it will be going to multiply because of the there will be a because of the kinetic energy, more immobile ions will be going to break down. So because of this, the M at the breakdown voltage multiplication M becomes infinite and the current rises abruptly in the breakdown region. So there will be a large change in the current with small changes in your applied voltage. How it is related is the avalanche multiplication factor relates between the VCB and the breakdown voltage BVCBO as 1 by 1 minus VCB by BVCBO the whole power n, where n is the constant. So it ranges between 2 and 10, depends on the type of material or the depends on the NPN transistor. So mostly PNP transistor it is 2 and for NPN transistor it should be 4. But it will be ranging from 2 to 10 to control the sharpness of the breakdown. So breakdown, there will be two types. One is avalanche breakdown and another one is punch through. So the punch through is also called as reach through. This happens due to the early effect. And the other one happens because of the multiplication of the immobile ions. So very important question. Prepare well. Thank you, students.